This is Professor Belton. This is part 4 of chapter 5, section 5. So pause the video, try these ones for yourself. You should be getting imaginary answers for the last couple zeros. All right, so if we do the P and Q list here, so P in this case is 9. Let's just try that over again. I don't know what happened there. Okay, so, whoops, that didn't even work to do anything. Come on. There we go. So P is 9 and Q is 4, right? P is the constant and leading coefficient is 4, which is Q. Okay, so the factors of 9 are 1, 3, and 9. The factors of 4 are 1, 2, and 4. Okay, so plus or minus P over Q equals plus or minus. We'll make our list of possible answers or possible zeros. So 1 over 1, 1 over 2, 1 over 4, 3 over 1, 3 over 2, and 3 over 4. And then 9 over 1, 9 over 2, 9 over 4. Okay, so if I look at the graph, I notice it looks like it goes through approximately negative 1/2 and 3. So I'll try those ones. So negative 1/2. Okay, so 4, negative 10, 0, negative 15, and negative 9, because you notice that there's no x squared term here, so I have to include that. So I'm going to add, multiply by negative 1/2. I'm going to add, multiply by negative 1/2. I'm going to add, multiply by negative 1/2. I'm going to add, and then multiply by negative 1/2. It looks like that worked out. So f of x is equal to x plus 1/2 will give me negative 1/2 when I solve, and then 4x minus 12x plus 6x minus 18. The original problem was a fourth, so now I'm down to 3 because I factored 1 out. Okay, so I also noticed when I graphed it that it looked like it went through the 3 and the x-axis, the x-intercept. So I'll try that one. 4, negative 12, and 6 and negative 18. Okay, so what you'll notice is 3 and negative 1/2 are in my list up there. Okay, and you don't need to do the ones that don't work. If it doesn't work, don't list it in your work. So I'm going to add, multiply by 3. I'm going to add, multiply by 3. I'm going to add, and then multiply by 3. Okay, so it looks like we have one that works, right? All right, so f of x equals x plus 1/2, and then x minus 3 will give me positive 3, and then 4x plus 0x plus 6. So the one prior to this was 3, so now this is down to 2, since I took 1 out. Okay, so I noticed that the 4 and the 6 have a common factor of 2, so I'll take that out. So f of x equals 2, so I'll divide that out, or factor that out. So x minus 3, so if I factor out a 2, I'm left with 2x squared plus 3. Okay, and if you notice, 2 times 3 is 6, no factors of 6 will give you 0, so to solve that one individually. Okay, so if I solve that one individually, right, 2x squared plus 3 is equal to 0. So you have 2x squared equals negative 3, or x squared equals negative 3 over 2. So if I square root that, I got a couple problems here. First is a negative in the inside, which comes out as an I, but I also need to multiply by root 2 over root 2. So what I really have here is x equals plus or minus root 3 over root 2, and I have an I, which I'm going to put on the outside, which is the negative I took out. So I'm going to multiply by root 2 over root 2. That didn't work out too good. Let me try that again. So x equals plus or minus root 6 over 2 I. Okay, so that actually works a little bit better because the root 2 times root 2 is root 4, which is actually square root of 2. Okay, so if you actually factor it out, f of x equals, what do we have here? 2, and then x plus 1/2. Some people actually combine the 2 and the x plus 1/2 to get 2x plus 1. and then x minus 3, and then x minus root 6 over 2i, and then x plus root 6 over 2i. I kind of ran out of room there, right? So those are my factors. Apologize for the spacing there. So my zeros, right? X equals -1/2, positive 3, 6, I'm sorry, root 6, I almost put 6. Root 6 over 2i, and negative root 6. Wow. Negative root 6 over 2i. There we go. Okay, so that one we didn't need quadratic formula for. We just solved using basic algebra. This one, however, you're going to need to use quadratic formula for. Okay. All right, so here the p is 4, the constant, and the coefficient is 1, right? There's a 1 there. So the factors of 4 are 1, 2, and 4. The factors of the q are only 1. So the list of possible rational answers, because again, we're getting imaginary answers, which are fine. They just won't be in this list. Right? This list is only the rational answers, not the imaginary or irrational answers. Okay, so 1 over 1, 2 over 1, and 4 over 1 are the possible rational answers. You always want to find those first and find the irrational imaginary answers second. Okay, so looking at the graph, it looks like it hits 1 and bounces off. Okay, and 1 is one of my possibilities, so we'll try 1. So 1, -3, 5, -1, -6, and 4. Okay, so I'm going to add, multiply by 1, 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 and then add. Oh, that worked out perfectly. So f of x is x minus 1 will give me a 1, right? And then 1x minus 2x plus 3x plus 2x minus 4. So the original problem was a fifth, right? So now this is 4 because we took 1 out. Okay, so I saw that it bounced off the graph, which tells me it's multiplicity, right? Because if it goes through, it's odd. If it bounces off, it's even, right? So 1, -2, 3, 2, and -4. Okay, so 1, I'm going to add, then I'm going to multiply by 1. I'm going to add, then multiply by 1, then I'm going to add, multiply by 1, then I'm going to add, then I'm going to multiply by 1. Oh, looks like that worked. So I get f of x equals x minus 1 a second time. So now I'm left with 1x minus 1x plus 2x plus 4. The prior problem was 4, so now this is down to 3 since we took 1 out. Okay. All right, so I also notice it goes through -1. Okay. So if I do -1, 1, -1, 2, and 4. So I'm going to add, multiply by -1. I'm going to add, multiply by -1. I'm going to add, and then multiply by -1. Okay, so it looks like that works. Let's write that over here. So f of x equals, I have x minus 1 twice, and I just took out a -1. So if I take out a -1, that's x plus 1 as a factor. And I'm left with 1x minus 2x plus 4. Okay, and since the prior one I was factoring was 3, now I'm down to 2. Okay, and what you notice is 1 times 4 is 1 times 4 or 2 times 2. But none of those will give me the -2 in the middle, right? So as a result, it's not factorable, which means the last two answers are not rational, right? So they're either irrational or they're imaginary. So we'll do quadratic formula. So we have to because it's a trinomial, right? So x equals -b plus or minus b squared minus 4ac all over 2 A, right? So that's A, there's B, and there's C, right? So x equals 2 plus or minus the square root of 4 minus 16 over 2. I don't know why I made that so long. I know it's kind of weird, right? So I get 2 plus or minus root negative 12 over 2. So I get 2 over 2 plus or minus the square root of 2, 2, 3, and then the I comes out, right? So x equals 1 plus or minus 2 root 3 over 2i, right? So those cancel. So I get 1 plus or minus root 3i. Okay. All right, so I have two imaginary answers here. So my function is x minus 1 squared, x plus 1. We'll do brackets here. X minus 1 plus root 3i. And x minus 1 minus root 3i. Okay, so those are my factors, right? So my zeros. Okay, we got what? 1, negative 1, and then 1 plus root 3i, and then 1 minus root 3i. Okay, so you're either going to get rational, irrational, or imaginary answers. If you have irrational or imaginary, you're going to get 2 in the end, because you had to have done a square root or a quadratic formula, which involves a square root. Okay, let's try the last page. So we did the irrational conjugate theorem. Now we're going to do the complex conjugate theorem, which is similar, right? Same idea. If you had a plus bi, then you must have a minus bi. If you had a minus bi, you must have a plus bi, essentially, right? Which we just showed in the prior page, solving for those. So now we're going to go from the other perspective. What if I give you the zeros, you give me the function? So we're going the other way. Okay, so the function has there's infinite number of functions that go through these zeros, right? So f of x equals a. So x plus 3, whoops, and x minus 2 will take care of these two zeros, right? Because the x plus 3 solved will give you negative 3, and x minus 2 solved will give you 2. And then we have x minus I and x plus I, because I couldn't have had just one, I had to have had both, right? If you give I as an answer. Okay, so f of x equals, so similar to the complex, I'm sorry, not these are the complex ones. Similar to the irrational ones, combine the like ones first, don't just go left to right. So x squared minus 2x plus 3x minus 6, right? Because a lot of these will cancel out. So if I combine the I ones, I get x squared plus ix minus I squared. So I get f of x equals a, x squared plus 1x minus 6, and then x squared, and then if you think about it, this is going to be minus negative 1, because I squared is negative 1, right? So f of x equals a, x squared plus 1x minus 6, and then x squared plus 1. Okay, so we're almost done. So f of x equals a. All right, so 3 terms times 2 terms should be 6 terms, right? So we start with this one, that gives me x to the 4th plus 1x squared. So this one gives me plus 1x to the 3rd plus 1x. And then this one here, minus 6x squared minus 6. So that's 1, 2, 3, 4, 5, 6. Perfect. So f of x equals a, x to the 4th. Let's see, we have a 1/3 there, so plus x to the 3rd. So there's 1 minus 6, that's minus 5x squared. And then we have plus 1x, and then minus 6. Okay, so we need one, so there are infinite number of functions that go through these zeros. So I need one coordinate that has to be given to figure out what the specific function is. So 100 equals a, and if I plug in -2, so that's -2 to the 4th plus -2 to the 3rd minus 5 times -2 squared plus 1 times -2 minus 6. So 100 equals a. Okay, so that's going to be 2 to the 4th is 16. That's going to be minus 8. So -2 squared is 4 times -5 is -20. Minus 2 and then minus 6. So I think we're good there. So if I think about it, that'll cancel out, leaving me -20. So 100 equals a times -20. So if I divide by -20, a equals -5, right? -5, come on. So that's going to go back into here to get my actual real function, right? So my actual function, just double check here. I think we're good. Yes, I'm just going to times it by -5. All right, so -5x to the 4th. -5x to the 3rd. Let's see, it's already a -5, so it'd be 25x squared minus 5x. So minus 5 times -6 is what, positive 30? Okay, so there's our function. All right, pause the video, try the student problem for yourself. Oh, we got a typo here. That doesn't go there. That's the right problem. Okay, so again, we're going for least degree, so we're just going to assume they don't repeat themselves, essentially. Okay, so f of x equals a. So we have x minus 2 and then x plus 1. I think I got a little bit of a typo there. So there's the 2, and this negative here actually goes with the 1 that's over here. I kind of drifted over for some reason. And then we have x minus 1 minus 3i. And then x minus 1 plus 3i. Okay, so f of x equals a. So this is x squared minus 2x plus 1x minus 2. Then here I'll distribute these first. So it's x minus 1 minus 3i, and x minus 1, I'm sorry, that's plus 3i. And this one's 3i, minus 3i, excuse me. All right, so f of x equals a, x squared minus 1x minus 2. I think we're good there. All right, so 3 things times 3 things should give me 9 things. This is x squared, when I start with this one, minus 1x minus 3ix. And the -1 would be minus 1x plus 1 plus 3i. And then lastly, plus 3ix minus 3i, and then minus 9i squared. Okay, so if you look through here, a bunch of stuff should cancel. So plus 3i minus 3i, 3ix and 3ix cancel. Okay, so we'll combine what we have left. So f of x equals a, x squared minus 1x minus 2. So I have x squared minus 2x. So if I think about this, this is 1, and that's actually positive 9, so I get a 10, right? You think about why that is, because this is -9 times -1, because I squared is -1, right? Because I is the square root of negative 1. So I squared is the square root of negative 1 squared, right? Which is just negative 1, right? Although I can't write very well. There we go. Okay, so 3 things times 3 things should give me 9 things here. So 3 terms times 3 terms is 9 terms. All right, so starting with this one. So that's x to the 4th minus 2x to the 3rd plus 10x squared. Okay, next one. Minus 1x to the 3rd plus 2x squared minus 10x. Okay, so the last one, minus 2. So minus 2x squared plus 4x, and then minus 20. Okay, so that gives me 1, 2, 3, 4, 5, 6, 7, 8. That gives me 9 terms. Perfect. That's what we wanted, right? So f of x equals a. So you have x to the 4th. Okay, so if we look at the 3rd power, we have a minus 2 and a minus 1 for minus 3. X to the 3rd power. It's like a better 4 than that. Okay, so for 2, I have 10, 2, and minus 2. That just leaves me with 10. Okay, and then the 1st power, I have minus 10 and plus 4, so that's minus 6. And then minus 20 on the end. Okay, so there are an infinite number of functions that go through these zeros. So I need one coordinate to figure out its orientation. So when I plug in 1 for the x value, I get 36 for y. So 36 equals a. So if I plug in a 1, I'm going to get 1 minus 3 plus 10 minus 6 minus 20. Right? Because all I'm doing is plugging in 1. So 1 to any power is 1. So 36 equals a. So let's see here. If I think about this, this is going to be negative 18. Check me on that. So a is negative 2. So we're going to take that and plug it into there. Yep, okay. So if I plug that into there, I get f of x equals negative 2x to the 4th plus 6x to the 3rd minus 20x squared plus 12x plus 40. Okay, so that is the end of part 4.